Hello everyone, I am Sixun Huang from National Kaohsiung University of Science and Technology, Taiwan. This lecture will introduce basic digital image processing using OpenCV on Google Colab, which is a free cloud service for machine learning. The outline of this lecture includes Google Colab about why use Colab for writing machine learning algorithms, how to start Colab, and how to write the first Colab program. Basic image processing about what is OpenCV, and how to write the programs for loading an image from a file and accessing image values respectively. What you have to do when you are interested in exploring machine learning. Firstly, you have to buy a hardware accelerator, such as a GPU or TPU card. And then you have to install the hardware driver, such as CUDA. After that, you have to install the programming IDE that you favor and the libraries for machine learning, such as TensorFlow or PyTorch. After figuring out all install errors and completing system setup, you may lose your passion in machine learning. Colab is a free cloud service to encourage machine learning research. It has free GPU and TPU accelerators. It also provides Jupyter Notebook for Python programming and pre-installed ML libraries such as TensorFlow and PyTorch. In other words, Colab provides a free environment for machine learning. Therefore, by using Colab for machine learning, the only thing you have to do is registering a Google account. To start up Colab, we firstly link to Colab official website via the link colab.research.google.com. Then we click the Sign In button and enter the name and the password of the Google account. After login, we create a Jupyter Notebook for Python programming by selecting menu items from File to New Notebook. After creating a Jupyter Notebook, here shows Colab web page and IDE for Python programming. It mainly contains a file name, a main menu, and a sidebar menu, including table of contents, file and replace, code snippets, and files. Besides, a Connect drop-down menu has a sub-item Connect to hosted runtime for connecting to the hardware provided by Google Colab. For the area at the center of web page, it is the Jupyter Notebook for Python programming. A Jupyter Notebook is a list of code and test cells, where code cell is for writing Python code, and the test cell is for writing comments. These two buttons are for adding code and test cells to the notebook respectively. Here shows an example of the Jupyter Notebook that has a test cell and a code cell. By pressing the icon at the front end of the code cell, we can run the Python code in that cell, and its output will appear below. For manipulating the cells, you can use the items in the cell control menu, such as move cell up, move cell down, add a comment, or delete a cell. After briefly introducing the Colab IDE, we start to use Colab for writing the first Python program called Hello Colab. The first step is to rename your notebook as Hello Colab, and then set the hardware accelerator by selecting the Change Runtime Type item. We can set the hardware accelerator as none, GPU, or TPU. In this simple example, we set hardware accelerator as none. Next, we write the Python code as below to display the message Hello Colab. After that, we run the program by pressing this button or selecting the Run All menu item. Here shows the output of the program. After introducing how to write and run the first program in Colab IDE, we next talk about how to write the program for basic image processing by using OpenCV. OpenCV is an open source computer vision and machine learning software library that has more than 2,500 optimized algorithms in computer vision and machine learning fields. In addition, OpenCV has interfaces for C++, Python, Java, and MATLAB programming languages. Currently, OpenCV is the most popular and widely used software library for computer vision. Based on OpenCV, we introduce the program of how to load an image from a file. Before to write the program, we firstly upload a local image file to Google Cloud Drive. Then, we write a program to read in the image file and display it in Colab. For uploading an image file via Colab, we firstly mount the Google Cloud Drive. To achieve this, press this icon and select the Connect to Google Drive. After successful mounting and waiting for a moment, we can see a drive directory in Colab files. By expanding it, we can find a Colab notebooks directory that stores all Colab Jupyter notebooks. The next step is to click the button at the end of Colab notebooks and select the Upload menu item. This will activate your local file explorer. Then, we select an image file, for example lina.bmp, and press OK button to upload the image file. After that, we will see the name of the selected image file in Google Cloud Drive. Since Colab uses content\drive directory to refer to Google Cloud Drive, the full path of the uploaded image file will be content /drive /my drive /collab notebooks /lina.bmp. The code for image loading consists of 3 steps. Firstly, we import 2 packages, including OpenCV and Google.Colab. Secondly, we invoke imread in OpenCV package to read in an image file in Google Cloud Drive. Finally, we invoke CV2 _imshow in Google.Colab package to display the loaded image. The Python codes for the mentioned 3 steps are listed here respectively. By selecting Run All menu item, we will see that an image is showing in Colab. Next, we will talk about how to access the data in the loaded image. An image loaded by OpenCV is returned as a NumPy array. For a gray image, it is a 2D NumPy array, whose first axis is image height, and the second axis is image width. For a color image, it is a 3D NumPy array, whose the first 2 axes are image height and width respectively, and the third axis is the number of color channels. In general, a color image has 3 channels in sequence respectively for blue, green, and red. Accordingly, for accessing a single pixel, we can use single element indexing for NumPy array. For example, this code reads the value of the pixel at 2030 to the variable p sub value. For this code, it sets the value of the pixel at 2030 as 255,000, that is blue. For accessing a block, we can use array slicing for NumPy array. For example, this code reads in all pixels in the block with height ranging from 20 to 40 and width ranging from 30 to 50 to the variable b sub value. For this code, it sets the same block as the blue color by writing the value 255,000 to all pixels in that block. In this video, we firstly talk about the advantages of using Colab and how to log in and start up Colab. Then we describe how to mount Google Cloud Drive and upload an image file from localhost to Google Cloud Drive. After that, we detail the way and show the codes for loading an image file and accessing a pixel or a block of a loaded image. Thanks for your listening and have a nice day.